Hi, my name is Boris Kourtoukov, and today I will present to you a paper titled Monarch V2, an iterative design approach to prototyping a wearable electronics project, co-authored with Kate Hartman, Izzie Colpitts-Campbell, and Erin Lewis. Monarch is a wearable electronics prototype that enables the wearer to amplify or extend body language through the use of a muscle-activated kinetic textile. By flexing and releasing the bicep muscle, sensed by an electromyography sensor, the wearer is able to raise and lower wing-like textile structures located on the shoulders as a way to express enthusiasm, excitement, assertion, aggression, mischievousness, or even flirtation. This pictorial details the second prototype stage, with a focus on addressing the wearability, technical, and production challenges resulting from the first prototype. The first prototype of Monarch served as a successful proof of concept, technology, and interaction. However, like many first wearable prototypes, it was cumbersome to wear, sized to a limited number of people, laborious to make, difficult to maintain, and challenging to produce. Going forward, we wanted to produce a version of this wearable device that brought it to a next level of polish in terms of wearability and usability. The second version aims to achieve a high enough production quality so as to further explore our initial speculations on how a body-based technology can be used as a form of personal expression, how the behavior of wearable garments can be controlled through the movement of our bodies, and how wearable technologies can begin to feel like a visceral extension of the self. The aim of producing Monarch V2 is as follows: resolving the wearability challenges so the wearers are able to focus on wearing and actuating the device and experience the resulting social interactions rather than be distracted by elements of physical discomfort. Resolve technical challenges so the wearers are able to undertake more durational testing in an everyday environment without direct observation and technical support. Resolve production challenges so as to create a robust set of multiples that can be worn by multiple users at once in a large social context. This pictorial presents recommendations for prototyping processes of small batch wearable electronics prototypes produced in a research lab contexts. The goals of Monarch V2 addresses a variety of areas of refinement, including the servo motor selection, pleated textile production process, personal customization options, weight distribution strategies, and improved efficiency for production of multiple units. The sections that follow detail the technical developments, design processes, material choices, and production methods used in Monarch V2 as compared to Monarch V1. The harness provides housing for the circuitry and securely positions the motor and wings on the wearer's shoulders. The top priority in redesigning the harness was to improve wearability. The specific wearability issues in V1 included discomfort caused by the neck and waist closures, as well as problematic positioning of the control panel and the main circuit board. The V2 harness features thinner straps that go under the arms rather than around the waist, similar to the style of backpack or holster. They're constructed with leather, stretch elastic, and buckle to allow for sizing adjustment. The V2 control panel was relocated to the shoulder for improved reachability. The harness was developed to include a racerback design made with a wet mold leather so as to create an enclosure for electronic components. A custom fabric lining secures circuit boards and batteries in place. A laser-cut design was developed to include holes, cutouts for rivets, and openings for the control panel. The natural vegetable tan leather allowed us to laser cut the material, adding speed and consistency when creating multiples. A detailed lining was designed with channels and pockets stitched to the leather with a saddle stitch. Monarch's wings are actuated by servo motors. The servo mechanism is a unit that includes the fixturing of the servo to the base and an attachment for the servo arm. The V1 servo mechanism used a total leather enclosure, preventing easy repairability. In V1, all of the weight was placed directly on the servo arm. The servo arm is off-center within the moving textile, greatly reducing movement. The V2 servo mechanism has a parametric 3D printed design and prioritizes repairability and precision. It uses a bracket that reduces the weight placed on the arm of the servo. The bracket also makes it possible to have the moving arm be centered in the wing. The V2 servo mount design also includes the following: a new attachment method. A leather strip affixed with 2 rivets is used to attach the mount to the leather base. An arm fixture with bolt retains the wire extension that lifts the textile wiring. A rotation point that secures the servo arm on one side with a freely moving bolt on the other. From V1 to V2, there was a significant shift in material approach of the pleated textile wings. V1 used a 2-material approach, a denim-based textile that acted as a hinge and a set of laser-cut felt strips in the shape of the negative space between folds that provided structure to the shape. Each felt strip had to be ironed on individually. This process was very labor-intensive and not suitable for making multiples. V2 uses a canvas fabric with digitally printed fold guides. A method of ironing and starching was used to create long-lasting pleats. The use of digitally printed fabric had the added benefit of allowing each Monarch to be customized by its wearers without disrupting the production process. The development of the V2 circuit focused on the ease of assembly, long-term stability, and overall robustness. Moving from protoboard to a printed circuit board increased stability of the electrical connections and reduced the vertical profile of the board. Conventional terminal blocks were replaced with quick-release connectors, which greatly improved the ease of connecting, disconnecting, removing signal noise due to poor connection, and relieved strain on the wires. The EMG sensor remains the same across versions, but the PCB traces provide a much less noisy connection. In Monarch V1, all of the electronics were housed in a large pocket near the waist. The much more compact design of V2 places all electronics around the upper back area. Each component is designed to be detachable and replaceable. Here is Monarch V2 in motion. The goal of Monarch V2 was to produce a robust set of multiples for use in social scenarios. The aim of these physical refinements was to support the prototype's availability for repeated long-term use. We wanted to produce prototypes that could be tested in everyday life as a way to explore and enhance or extend the sense of embodiment through an augmented or extended body language. Through our prototyping process, we arrived at several recommendations which emerged from concerns specific to Monarch, but are able to be applied to prototyping processes for other wearable electronics projects produced in research lab contexts. Recommendation 1. The integration of digital fabrication processes, laser cutting, 3D printing, digital printing fabrics, can allow for improved precision and reproducibility of wearable electronics projects. In Monarch V2, this can be seen in the laser-cut leather harness, the 3D printed servo mechanism, and digitally printed textiles. Recommendation 2. Hybrid production methods are sometimes essential in order to address wearability priorities. The assembly of Monarch V2 remains a bespoke production. Through our prototyping process, we discovered that the feeling of refinement, comfort, and wearability that comes from the V2 design is a direct result of the combination of the use of digital fabrication methods for the preparation of materials and the detailed craftsmanship involved in the assembly. Recommendation 3. Modularity of parts, both electronic and not, can allow for repair, refinement, and customization. In the Monarch V2, all electronic components can be easily connected and disconnected using robust connectors, which supports repair processes and the use of parts and components across multiple units. Similarly, the wing-like textile structures can be completely detached and swapped so the wearer is able to customize. This overview of Monarch V2 highlights the improved material choices, production methods, technical developments, and design processes that resulted in improved wearability, technical reliability, and reproducibility. The documentation of the design and prototyping decisions, as well as the resulting recommendations, are offered as a case study contributions for other researchers aiming to develop small batch productions of wearable electronic research artifacts. This iterative design process yielded 6 functionally identical units of the Monarch V2 design that are well equipped for durational testing in the context of daily life. To see the references in detail, please check our paper. We would like to thank the contributors to our project. And for more information about this and other projects, please visit socialbodylab.com.